Part 2 is about the tests for various gases. We will be doing tests on carbon dioxide, hydrogen, and ammonia. Carbon dioxide is an acidic gas. So it is neutralized by calcium hydroxide, aka lime water, and it will give a white precipitate when we bubble the gas through lime water. So I'm getting ready a solution of lime water right here in my test tube. And we will prepare the carbon dioxide through an acid-base reaction involving hydrochloric acid and sodium carbonate. So I'm going to add some hydrochloric acid to a test tube. And we're going to scoop in some solid sodium carbonate. We expect to see brisk effervescence. So ready? Here goes. Wow, brisk effervescence. Quick, let's get some gas. And let's bubble the gas through lime water. Wow, do you see it? A white precipitate is appearing. Do you see it? Yes, so that's the white precipitate you get when you bubble carbon dioxide through lime water. So now we're going to do the test for hydrogen. Hydrogen will be prepared by adding hydrochloric acid to magnesium. Here I have some magnesium ribbon. When I add the magnesium into the HCl, there will be effervescence of hydrogen formed. So let's see. I'm going to add the magnesium ribbon in now. Oh, effervescence. That's hydrogen. Let's stopper the test tube to let the hydrogen collect. For hydrogen, we'll be using the lighted splint test. Hydrogen gives a pop sound with a lighted splint because the hydrogen that is formed will cause a mini explosion when it reacts with the oxygen around it. Next up, we have the test for ammonia. Ammonia is a base, so it will turn moist red litmus paper blue. We are going to generate the ammonia by adding sodium hydroxide to ammonium sulfate. Ammonium is an acidic cation. When we add sodium hydroxide to ammonium sulfate, an acid-base reaction happens. The ammonium is neutralized to form ammonia gas, but ammonia gas is a soluble gas, so it's still in solution. But because it's a gas, when we warm the solution, ammonia will be released. All we need to do is to get ready to test for it. So I have my Bunsen burner ready. I have my litmus paper, which I will just add a little bit of deionized water to it, just to make it a bit moist. Boiling tube ready. Let's do the warming. And I will place the litmus paper near the mouth of the boiling tube. You can see it's turning blue already. So that's how you test for the various gases. Thank you. So part 3 is about the test for the amphoteric cations, chromium 3, aluminium, and zinc. So what we'll be doing is the sodium hydroxide test, where I'll be taking about 1 cm depth of chromium 3 and adding sodium hydroxide to it dropwise until in excess, chromium forms a grey-green precipitate with sodium hydroxide. So when we add the sodium hydroxide in, you can see that precipitate forming right here. And because chromium is amphoteric due to complex formation, when we add in excess sodium hydroxide, the precipitate dissolves to form a dark green solution. Now we are going to reverse the changes. We are going to reverse the changes by adding sulfuric acid dropwise to the dark green solution until in excess. If there's too much of the solution in the test tube, it's harder to reverse the changes. So I'm going to transfer some of the solution into an empty beaker, leaving just enough to create the observation that we want to see. I'm going to add sulfuric acid now, dropwise. The sulfuric acid will neutralize the sodium hydroxide there, and then we generate chromium 3 ions, which will cause the chromium hydroxide grey-green precipitate to reform. Once we add excess sulfuric acid, the chromium hydroxide is neutralized to reform chromium 3 ions, creating the color of the original solution that we saw. Let's repeat the procedure for aluminium and zinc. Let's start with aluminium first. So, same thing, about 1 cm depth of aluminium 3. We are going to add sodium hydroxide now, dropwise. Aluminium forms a white precipitate with sodium hydroxide. You can see the white precipitate forming already. Yes. Take care not to add too fast, too much. Otherwise, we can't see the white precipitate forming so clearly. Now when we add excess sodium hydroxide, the white precipitate is going to dissolve. Yes. Due to a complex formation, aluminum hydroxide soluble in excess to give a clear solution. Now we're going to reverse the changes. Same thing, let's transfer a bit of the solution to the beaker, leaving just enough to reverse the observation. Sulfuric acid goes in dropwise. We should see the white precipitate reform. Yes. Do you see it? Again, take care not to add the sulfuric acid too fast and too much. Otherwise, if the sulfuric acid is added in excess, then the clear solution is all you see. Last will be zinc. 1 cm depth of zinc. Sodium hydroxide goes in dropwise. Zinc hydroxide is a white precipitate, but it's not as visible as aluminum hydroxide. You can see that the color is actually a bit lighter. So you have to be extra careful when adding your sodium hydroxide. Like aluminum hydroxide, when you add excess sodium hydroxide, the precipitate dissolves due to a complex formation. So we're going to reverse the observations again. Let's add sulfuric acid dropwise. That will cause the white precipitate to reform. Slowly, slowly. You don't want to miss the precipitate coming out. Can you see it? The white precipitate reformed. Yes. Oh, it's gone now. That's what happens when you add too fast. The clear solution is the final result. Thank you. The last part of this experiment is to identify the anions present in this solution, Fa1. Fa1 contains two anions, which can either be carbonate, sulfate, chloride, bromide, or iodide. So the first test we will be doing is the silver nitrate test. What we are looking for in this test is the color of the precipitate. I'm going to add about 2 cm depth of Fa1 in the test tube. And we're going to add silver nitrate next. All the anions that I mentioned precipitate with silver. Silver iodide is a yellow precipitate. The rest are all white. So what I'm looking for is any yellow precipitate appearing. White precipitate. Let's add some more and see. It's all white. There's no yellow. It's all white. Let's add a bit more to confirm. It's just white precipitate. So there's no iodide ions present at all. Okay, so now we'll divide the solution into two portions. To one of the portions, we are going to add dilute nitric acid. What we are looking for here is any effervescence, because out of all the anions, the carbonate anion is basic. If we add nitric acid, there should be some effervescence. So let's see. Yes, I see effervescence. A little bit of bubbling. Tiny bubbles. Tiny bubbles. Oh, it's getting more vigorous. Yes. It must be because the silver carbonate precipitate is stuck to the walls of the test tube. Yes, let's try adding some more. Wow, okay. So there's carbonate anions inside for sure. What's the other anion? The next test we are going to do is the ammonia test. It could be sulfate, chloride, or bromide. What we are looking for is whether the precipitate dissolves. If it dissolves, it's silver chloride for sure. So I'm going to add ammonia in. Let's see any changes to the mass of the precipitate. Can you see some of the precipitate starting to dissolve? Yes, yes. Oh, a significant amount of precipitate dissolved. What's left at the bottom is just the undissolved silver carbonate. So based on the two tests that we did, we can conclude that the anions present are chloride and carbonate. Thank you.